Hello, welcome to the show. My name's Relvin. This is Do All the Things. On today's episode, I'm installing the field pump alarm, which I built in a previous episode. So if you saw that, well, here's the rest of it. Those of you interested in all the electronics might not have found this that interesting, which is the reason why I divided it up in two parts. But those of you of culture and style who like to know the full story, regardless of the genre, this is for you. Now, seen here is an existing control switch for the pump alarm. Basically, that turns on and off the power to it. So if it goes off in the middle of the night, I can just, switch her off and deal with it in the morning, because the field pump is a pump that doesn't need to be tended to right away. If you don't know what that is, I have a septic system in this house. All the sewage and water from the sinks and showers and whatnot goes out to a tank full of poo. Now, that tank only needs to store the poo. The water goes to a pump, and that pump pumps it out to the field bed in the backyard, where it gets dissipated into the environment. Sounds nasty, but it's really quite normal. Active field beds are more common because it's hard to do it naturally these days, especially with the suburban development kind of screwing up the natural flow of things. But either way, that pump's got to run. Now, it only has to do anything if you fill the tank. So if you don't run any water, it doesn't really have to run. So if it does fail and overflow and you get an alarm, you are free to just turn it off and deal with it in the morning. I'll explain more how this system works, but I want to get this installed. And it's going to go into this general area. Behind this wall, it's hollow and empty. I can reach my hand around and feel the back of it. Now, for reference, I'm going to take this plate off so I can see generally where the hole goes. This is a rework box, kind of similar to what I'm using, except it uses the bendy bits. Tried to get one of these, but you can't just buy two of these bendy bits often. I don't have to worry about turning off the power because I'm not tampering with this thing at all. This is a low voltage circuit I'm installing that plugs into a receptacle when I'm done. I got to figure out about where I want to put this thing. I'm just going to kind of slip my square in here. I'm going to feel around. Okay, there's a wire coming off this box, ends right about there. So in order to make room right about here, so this will be about the edge of it. I want it to be at the same plane as this thing, so I got to make a hole like that over here. Oh yeah, it's roughly square. I got a square against the trim. So I already decided that I want to start the box right here. How high up is this hole? It's on this 10 mark, even though that's more than 10 millimeters. That's 15 millimeters actually. Top of the hole is at 75. And then what's the width? Width is also about 75. Now I gotta kind of confirm that the box we're gonna be using fits in the same footprint. This is the boîte in question. Oh no, that definitely needs more width, bud. Def needs more width. What do we got? 85. Okay, so let's move this out to 85. Can you see in front of my head? We can get this door out of the way. Maybe get the camera a little tighter here. All right, 85. Mark it square. Is it gonna fit in that width profile? Yes, it will. Now we just gotta make ourselves some nice even lines. All right, that should do it. I cut a hole there and I can put my box in. Now I do have one of those articulating saws, the ones that kind of, but I don't want to use that because, they're gonna blow dust everywhere. That's not a mess I feel like cleaning up right now. For drywall, I often just use a utility knife. Just need to be careful. Start off by tracing the hole. Now once we have our circumference, I just kind of take the knife and I can just kind of work it in there. I'm gonna double check there's no wires back here. Yes. And then, gotta brush off some of the debris that builds up on the blade because it starts slowing you down. Due to the nature of what this stuff is made out of, drywall that is, your blade's toast after you do this. So this isn't exactly practical if you're doing it professionally because you're gonna blow through braids and it takes a lot of time. But for a homeowner doing a one-off, hey, might as well. I think they even make specialty hand saws for doing this. But again, homeowner doing a one-off, now I should buying a specialty tool and this will do fine. At the end of the day, you end up with a reasonably clean hole without making too much of a horrible mess. We'll just snoot it up with a vacuum real quick. I'm not sure if you're supposed to vacuum drywall dust, but again, for small one-off projects like this, So now in theory, I should just be able to shuck this pupper right in there. So what happens is you put it in and then these flaps, which seem to be jammed right now, these flaps fold out. Holy f, would you stop jamming? And then this will grip behind the drywall and then pinch it into place. I don't think I compensated for these screws. I just tighten her down. Not too tight, drywall's fragile after all. But that's not going anywhere. And then we got these blue Grommet de Fromage. They're actually quite cheesy. These are connectors, they call them, for the wires to pass into the box. I don't like the idea of these for actual Nomex, but for passing low voltage wires, it's just fine. Just gotta go ahead and give that a little bit of an install here. Just a little bit of an install. Or I can drop it. Voila. I'm gonna go ahead and get my power supply into place. It plugs into this receptacle right here, which feeds power from the from the float switch outside. Now I just have to route this cable someplace reasonable up to where I need it to be. A little bit of cable management. Yeah. Right. I'll just go through the little grommet hole here. Huh. Power! We're pretty much ready to shuck this pupper in there now. These long wires are gonna get cut to length once I know about where I'm gonna run it. Case first to getting it through our little grommet hole. Now we can kind of size this up. I'm gonna do a little bit of a loop-de-loo here just to reserve some slack. And then we'll plug in our power connector. Sure, let's loop-de-loo that too. But let's loop-de-loo them in the same direction, bud. Loop-de-loo, loop-de-loo. Everything should clear. So the wiring, just a little making it just a little tighty. Come on, wire, tuck in there. Oh, there we go. That should be good. Reach over, grab a screw so it does not escape on this. Now we gotta fit the bell. The bell already has a previously established living spot of like right about here. That's like frig all. Like it's right next to this thing. We can cut this like right short, like even like this much right here. Well, let's go get some wire shaping tools. Now, I wouldn't mind putting little fork connectors on this, but I don't have any in stock of that proper gauge, and I'm so not running out to the hardware store again for a one-off item. I might add them later. For the most part, it's okay to just spin a wire on there. You might want to tin the wire a little bit at the ends, but for the most part, we're getting this done, and then I can add that after. It's gonna be a little bit of a contortion getting in there. We'll start off by attaching on these wires. I'm gonna go through that hole there, and then up through this hole. It's gonna make a bit of a choke point. Want these wires to wrap around the same direction that the screw secures. That'll do. Finally, the other one goes here. Oh, that should do. It's gonna hang loose for a second. I'll just go ahead and screw the bell into place. Goes right here. Loose it first so we can line up the second hole. Oh, you're over there. There we go. Bell's not going anywhere. And really, I see no reason why we can't button this up now. It's done. Oh, there is a reason why we can't button it up. We need to do a little bit of erasure. Get our marks off the wall, or as best we can anyway. You'd think pencil would erase better, but apparently it doesn't. Good thing this is a utility room and not like a posh, fancy, you know, wedding ball. That's gonna have to do. Gotta rewrap our wires though. And just to make this AV friendly, make sure we orient the screws the same way. Put this guy back on. And now the alarm is armed. It should work now. Let us go test it. Now, if we romp right back quick out to the backyard, here is the field pump control totem. It is in that little sarcophagus right there. In there, we have a GFCI with a night light. I can see that light glowing from the kitchen window, so I know the pump has power. The GFCI load side also goes to that receptacle because this assembly won't plug in on that side. And then that is no GFCI, that's a bypass receptacle, so if the GFCI starts tripping, I can bypass it because a good working pump will not pop a GFCI. If the GFCI starts popping, it's because your pump's starting to wear out. Up here is the alarm. This is an extra float. Here we have a neon indicator and a switch. They are in parallel to that float. And if you know how neon lights work, if you put them in series with whatever the load is, enough current passes to make them glow. So the fact that that's glowing right now tells me that the alarm is plugged in and armed. Now if I flick this, it should simulate the float. And you can already hear from the different camera angle, but we got blinky light. What the frick? There's something wrong with the bell, bud. Well, it's wired correctly. Oh, there's something going wrong here, bud. Well, that's no frickin' good. Great, further troubleshooting. Well, an alarm that doesn't ring is no alarm at all, right? The only thing that's changed is the length of that wire. The power supply is the same, 8.4 volts. What's the load voltage? Sinks down to 7.6. Now what happens when it fires? 1.6 volts. Where'd all our voltage go, bud? There must be something shorting out. Let's take a look at that bell install. No, I don't see what would be wrong here. Oh! I loosened one of the screws and it started ringing. Well, that doesn't make any sense. Okay, so I think what's happening is when I screw it down, the frame deforms just enough that it changes the geometry of the hammer, because it's just kind of, it's not a good design. It's one of the reasons why I built this. It's one of the reasons why I built this circuit, so we could have more reliable operation. But that means it's gonna need a little bit of fitting. Oh, hey, I could just turn it off. That disables the alarm. Fitting like a kitten. The screws that I got in there are pretty short. I'm gonna use longer ones to get a bit of better bite with them sitting a little looser. Fortunately, if that bell comes loose, it should still work. And then I got some shim material here. Good thing we let ourselves a little bit of slack. Now hopefully, you know, these shims are like wedgies. If I can kind of get a piece, ooh, I got this wire here. I wish that was located differently. You know, if we just cut a bit of this, it'll give it something to pounce. Oh, what if can't let that move? Yeah, we either need looser screws or washers under there. The shim material's not gonna work for what we need. Maybe this is the reason why the bell was acting funny before I did this circuit. So basically where the screws come through, it's lower than the frame. So you need DTS so it doesn't deform as much. Maybe some of these rubber bras will do. And it was more so on this side. Okay, let's get our longer screws and shuck it up in there and see what happens. Come on, where are you? So just ever so slightly tightened up in there. Now what happens if I turn it on? Aha, fitting. Just needed some fitting. Fitting like a kitten. Ho ho. Talk about fitting, we gotta fit all this wire back in here, eh? A little bit of geometry in question. Uh-oh, what the heck, bud? You used to fit. Put that, oh boy. Let's just pull some slack out here. Bwah. What the? Oh, ho, 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 ho. You're a bastard. Okay, this time for sure. Mucho fingerprinto, that's wonderful. Bring! It's not the loudest thing in the world, but it's good enough. Wait, what was this camera on the whole time? Oh, derp. I gotta go ahead, turn it off here from now. Gotta go out and flick that switch outside. The only thing left to do now is to test it for real. Actually cut power to the field pump and see if it goes off when the pump fills up. From my experience, it actually could take a day or two before that tank overflows. Like one guy, yeah, even a shower doesn't fill it up. So I think we're in a good place. Now I'm wondering if I should give you a quick explanation on how this system works. Showing a bit of my cards there, but it can be interesting. So let's see. If not, well, there we have it. We got our new alarm in place. So now if something happens with the pump, yeah, what the hell was that? We're gonna know. It's improved. There's a duty cycle. There's control. There's light. There's an overall better sound. There's some reliable fitting. There's a whole recipe of niceties tying this all together. And now I'm just babbling. So if you like this, stay tuned, because I do stuff like this sometimes. The house is pretty good these days. Not gonna be putting much holes in the walls, but hey, other little circuits, other little funsies, yeah. I'm gonna improve my doorbell next. You know, I'm gonna put the head blob in front of this. You won't even see this. Yeah, okay.